A very pleasant hello to everyone listening to this video. Today I, Ulfat Ansari of Isabella Thoburn College, as a maths assignment today going to present a video among you, namely with the topic gradient, divergence, curls in tensor. Firstly, curl. Curl is when you cross del with a vector field. Note that the result of the curl is a vector field. We can say that curl's operation turns a vector field into another vector field. Curl f is del into cross f is equals to del by del x, del by del y, del by z into f1, f2 and f3. The curl of a vector field is again a vector field. The curl of a vector field is obtained by taking the vector product. It is also written as in the matrix form ijk del x by del x, del by del y, del by del z, f1, f2, f3. Here I have taken an example of curl which is x1 plus where f is x1 x plus y plus z, x minus y minus z, x square plus y square plus z, and taking its cross product we get the result as 2y plus 1i minus 2x minus ij plus 1 minus 1k, which comes out to be 2y plus 1 minus 2x and 0, which is the answer here. The divergence is what you get when you dot del with a vector field. Know that the result of divergence is a scalar function. We can say the divergence operation turns a vector field into a scalar field. If we take I as a contravariant vector, the divergence of ai is defined as a contradiction of ai, or in other words, the contradiction of covariant derivative of ai is defined as a divergence of vector ai. The divergence of ai is also denoted by divergence a, thus divergence ai is ai comma I. The divergence of a vector field in a scalar field, the divergence is generally denoted by div. The divergence of vector field can be calculated by taking the scalar product of the vector operator applied. If fxy is a vector field in the two dimension, then its divergence is del by del x del plus del j upon del y into f1 x1 xyi plus f2 xyj. The divergence of a vector field can be extended to three dimension and is given by del f1 upon del x, del f2 upon y, del f3 upon z. Here is an example to solve that x square I plus 2zj minus yk, and the answer comes out to be 2x plus 0 gives out to be 2x. The gradient is when you multiply del by a scalar function, then the result of gradient is a vector field. We can say the gradient operation turns a scalar field into vector field. Del f is del f by del x, del f by del y, del f by del z. The gradient of a scalar field is a vector field and whose magnitude is the rate of change of and which points is direction of greatest rate of increase of scalar field. If vector is resolved, its component represent the rate of change of scalar field with respect to each directional component. Let phi be a scalar or invariant covariant xi derivative and is denoted by phi dash I, and is defined as the ordinary partial derivative of phi with regards to xi. Thus phi I is equals to del phi upon del xi. Del phi is equals to del f by del xi is equals to grad phi. If we look at the properties of gradient, we can change the vector field into scalar only if the given vector is differential. The given vector must be differential to apply the gradient phenomena. The gradient of any scalar field shows its rate and direction of space change in space. Example is x square plus y plus z. To solve it, we will get del f by del x is 2xy, del f by del y is x square, del f by del z is 1. The answer comes out to be 2xyi vector x square j vector plus k vector. The theorems are: if ai is a contravariant vector, then divergence ai is 1 upon under root g del by del xi ai under root g. The second theorem is divergence a subscript is equals to divergence a superscript. The theorem third is grade phi nabla is phi grad nabla plus nabla grad phi. The fourth theorem is divergence phi a is equals to grad phi dot a plus phi divergent A. And if we look at the curl of a vector, that ai be a contravariant vector, then we have aij del ai upon del xj is minus ap pij. Interchanging the suffix ij, we get pij is equals to pji. Thus we get aji is equals to del aj upon del xi minus ap in curly bracket pij. And we find that aij minus aji is equals to del ai upon del xj minus del ag minus del xi. Thank you for listening to this video. Hope you learned something from it.